don't draw this. I just want to show you what we got so far. We got the point 0, 10, and it's a fake. We've got the point 3, negative 17, and it's way down here, and it's a minimum. And we know that we have decreasing, decreasing, increasing. But the question is, when we draw this increasing part, we could draw it like that, or we could draw it like this. Concave down or concave up. And we got to know which way this thing's going to go, and that's where the second derivative test comes in, to help us know which way it's going to go. And this part that's decreasing, well, does it look like this or does it look like that? Both are decreasing, but one is concave up, one is concave down. So we've got to figure out what's going on in more detail than what we did last week.
Could you do that for the middle part too?
Yeah. Yeah, flip it around.
On the decreasing values, can you just make it one set of points?
Oh, from negative infinity to 3? Well, no, because well, it depends on which professor you ask. But you're asking me, so I'm going to tell you what I would say. At 0, the slope is 0, right? At x equals 0, the slope is 0. So if the slope is 0, are you decreasing or increasing? Neither. So we're decreasing all the way to 0, and then we're decreasing after 0, but not at 0. Sometimes professors would say, well, if you're decreasing at every point around it, you must be decreasing at 0, even though it doesn't look like it.
Which is wrong.
I think it's crap. Just being blunt.
I bet being in college sucked for you. You thought the professors were wrong.
It really did. You know, it's tough when you know you're right and then people around you insist that they're right.
You can't say nothing about it.
Because what can you do? Really. You could either keep your friends or you could be honest with them.
What's the honest
Who
side?
needs friends?
Second derivative test.
That's all we need.
So we go back to our first derivative and we do the derivative of that. The derivative of 4x cubed is 12x squared. Who said that all you need is, that's your friend, your second derivative, that's all you need? That's not one of you were making that point. It's about right. Minus 12x squared, negative 24x. So you got your second derivative, and you do exactly with it what you did with the first derivative. You set it equal to 0 and you solve it. Factor out of 12x, x minus 2. Set each part equal to 0, you get x equals 0, you get x equals 2. Over here on the side, I don't put CP, I put IP. IP stands for inflection points. Could they be fakes?
Yes, they could.
They could be.
So, since 0 was a fake on the first one, would it be on the second?
Yeah, that's a good question. 0 was a fake on the first one. Well, now we got 0 popping up again. It may be a fake, but it might not be. The only way we'll know is if we do our little test, second derivative test. 0, 2.
This is crazy.
Really?
It is to me, and I don't know.
Well, you skipped a day last week, right?
I didn't skip any day this week. I was singing choir.
Speaking of skipping, doing Friday, what do you?
Look on the calendar and see.
Next Friday.
Okay, now, remember you got to get the y values. So plug a 0 back into the original. We already know that that's 10. Plug a 2 back into the original. So I go back up here and I plug a 2 in. 2 to the 4th is 16. Minus 2 cubed is 8. That's times 4 is 32 plus 10. 26 minus negative 6. Now I've got to test those and see if they really are inflection points. And I've tested them by plugging them back into the second derivative. And this is why last week I told you, at the end of your first derivative number line, you need to put an f prime. Because you plug those into f prime. Because now we've got another number line, we're going to plug those into the second derivative. So I plug in a negative 1 into my second derivative, negative in front, negative in middle. That's negative times negative, which is positive. From 0 to 2, I plug in a 1. That's positive, that's negative, that's negative. So 0 is a real inflection point. And then I plug in a 3, but it's positive, that's positive, that's positive. 2 is also a real inflection point. So good for both of them. I don't label them as maximums or minimums, because that's not what we're doing here. what we're doing is we're trying to figure out where is the graph concave up or concave down. Whenever the second derivative is positive, our graph is concave up. So I'm going to say concave up, and that's from negative infinity to 0 and from 2 to infinity. These are intervals of x, not ordered pairs. We will be concave down from 0 to 2. Now I want you to stop and really appreciate this for a second. Because you might not appreciate, after all of that work, you might not appreciate how nice it is when you think concave up, which looks like this. Don't you think positive, happy thoughts? Concave up is when your second derivative is positive. It really could have worked out where concave up, which looks like smiling, was actually negative. But it doesn't. It works the way you would think. When you think positive, you think up. When you think negative, you think down. And that's the way the second derivative thing works. So appreciate that. And now we are prepared to draw a completely accurate graph.
Good, thank you.
Now, first thing you do when you draw an accurate graph is you go back and you plot your points that you know. We know the point 0, 10. Now, it is a fake. It's not a maximum or a minimum, but it is a point. And I also have the point 3, negative 17. I also have the point, an inflection point, 2, negative 6. Now this is a minimum point right here. This point is an inflection point. This point is a fake. Now at that fake, don't we know that the derivative equals 0? Which means slope. So even though it's a fake, which is not great, we do know that our graph has to level off there. We know that. Now we also know this. We know that we are decreasing from negative infinity to 0. We are decreasing from 0 to 3. And we're increasing from 3 to infinity. So I'm going to draw this, but then I'm going to erase it. We're going to be going downhill, downhill, and then uphill. That's the decreasing, increasing thing. But now I need to get my concavity thing in there. We are concave up from 0 to 3. That means we are smiling from negative infinity to 0. Why did I say 0 to 3? Concave up from negative infinity to 0. So we are going to be concave up, smiling. You see how I'm leveling off to a slope of 0 right here at that fake? The way I should be. And then we are concave up from 2 to infinity. Well, here's my point 2. Now I've got to touch my minimum point, so I am concave up there. I am concave down, though, from 0 to 2. That means I am frowning, so I am concave down for that part. That graph that I just drew is every bit as good as a graph, maybe even better than what your calculator would do. I'm going to say better. Because will your calculator graph in red and black and green and blues? So I win.
That's a good.
They have Cassiopeia. Any questions with that big process? That is, I know, a big process. There's a lot to that. Okay, tomorrow, no, we're not done yet, but I just want to say tomorrow I'm going to go through an example with a harder equation. This one that we just got finished